Alright everyone, so welcome back to the part 2 of the topical MCQs of cell microscopy. In this video, we will be discussing the remaining MCQs of cell microscopy. Alright, so let's move on to question 13, which is from March 2019, paper 1 to question 1. It over here says that the diagram below was drawn from an electron micrograph of an animal cell. They have drawn an animal cell of an electron micrograph over here. They are saying that which diagram would represent the same cell seen under a simple light microscope using the daylight as the only light source. Alright, so you must know the micrographs that which what Alright, in order to solve this question, you must know that how a cell looks under a light microscope as well as under a electron microscope, right? Let me attach an image. Alright, so the image may not be that clear to all of you, but however, we can see it for the reference. They are saying that what cell is representing the cell under the light microscope, right? In the light microscope we cannot see the smooth endoplasmic reticulum, right? These are the endoplasmic reticulum, the smooth endoplasmic reticulum, and if we see over here, so this is the animal cell under the light microscope, so we cannot see any smooth endoplasmic reticulum, so hence B would be incorrect. And in option C, they are showing us the mitochondria and the centrioles. The mitochondria, the so much intense structure of the mitochondria, the ultrastructure of the mitochondria is seen with the electron microscope and not from the electron microscope and not from the light microscope, as well as centrioles can also not be seen from the light microscope, hence option C is also incorrect. Then if I talk about option D over here, so you can see that over here in the animal cell under the light microscope, the double membrane of the nuclear envelope is not visible, right, in the light microscope cell structure, whereas in option D we can see the double membrane nuclear envelope, so hence option D is also incorrect. So the correct answer for this MCQ is option A over here, right? I hope that this MCQ is clear to all of you. Alright, so now let's move on to question 14 over here. This question 14 is from March 2019, paper 1 to question 3. It over here says that the diagram shows a fin whale drawn to scale. A student made 3 statements about the diagram. Which statements are correct? The magnification is into 0.006. So to calculate the magnification, we will do image length divided by the actual length. The actual length is given to us, which is 3 meters, right? And we will calculate the image length by using the scale. We are going to measure the scale bar, and whatever value will come, we are going to convert it into meters, right? So if I do it on a piece of paper, so it was coming to be about 1.8 centimeters, and then I converted it into meters, right? So if I converted into meters, so my value was coming to be about 1.8 divided by 100, it was 0.018, right? And then we divided by 3, so 0.018, and then as we divided by 3, so our value was coming to be about 10 into 10 raised to the power minus 3. So it was 0.006, hence statement 1 is correct, right? And then if I talk about statement 2, the ratio of actual size to the diagram size, right? Actual size to the diagram size, basically now I believe they are talking about this whole length over here. No, not this length. Basically actual size to the diagram size, actual size we have 3, right? To the diagram size we are having 0.018, right? And if we divide these values, 0.018, 3 divided by 0.018, we will get 166.6 ratio 1. This is what we are going to get, right? So hence statement 2 over here is incorrect. It is not matching with the ratio. Now this statement 3 is saying the fin whale has an actual length of 24 meters. Let's now Let's now solve this MCQs by using the elimination method, because now this is confusing over here that the fin whale has an actual length of 24 meters. Now we don't know that they are talking about this whole length or they are talking about this length. Like, this is a little confusing over here, right? So we can, what we can do, that we can use an elimination method to solve the question. 2 is incorrect, so all the, we know, we are pretty sure and we are 100% sure that 2, the statement 2 is incorrect, right? So we will eliminate all those options which are having 2 in it, right? Incorrect, incorrect, and we know that 1 is 100% correct, right? We have solved it, we have got our answer, and we know that 1 is 100% correct, right? So 1 will be our answer, and we don't know about 3, so hence the answer over here would be option C, 1 and 3 only, right? We don't have to solve it any further. So hence the correct answer over here would be option C. In question 15, which is from October November 18, paper 1 to question 1, they are saying that what is the diameter of a typical prokaryote such as Streptococcus. Alright, so you have to learn this value, a range of this value of a diameter of a typical prokaryote from your notes, which is to be 0.5 to be 5 micrometers, right? And you can over here see that mostly the answers are in nanometers. Two options are in nanometers and two options are in micrometers. So in micrometers you got the range, that in the micrometer your range is coming to be from 0.5 to 5 micrometers, and if we convert this into nanometers, so it would be 500 to 5000 nanometers, right? Let's see that what can be our correct answer. This is the range of a typical prokaryote, right? This is a estimated range. Now we have to judge by our estimation that what could be the diameter of a typical prokaryote. If I say that 7.5 into 10 raised to the power 1 nanometer would be 75, right? Point will move over here, and then it would be 750 nanometers, it would be 75 nanometers, it would be 7.5 micrometers, and it would be 75 micrometers, right? So in micrometers both of the options are incorrect because they are not lying under this range, but they are exceeding this range, right? And if I talk about the option A, which is 75 nanometers, so we know that the range is starting from 500 nanometers and going to 5000 nanometers. So hence the correct answer over here would be option B, which is showing us 750 nanometers, which comes under this range of the typical diameter of a prokaryote. So hence the correct answer over here would be option B. Alright, so now let's move on to question 16, which is from May June 18, paper 1 question 1. It says that which statements about the resolution and magnification are correct. We know the definition of the magnification is the ability to distinguish between the two separate objects that are very close together, right? It can also be the clarity of the image formed by the microscope, but we have to see the definition of magnification as well. Magnification is the number of times larger an image is compared with the real size of the object. Yes, this is correct definition of magnification. The power of the microscope to focus on very small objects. No, this cannot be the definition of magnification, I believe. No, it cannot be. Right? So hence the correct answer over here would be option A. These are the correct definitions. These are the correct statements which are about the resolution and the magnification. So this question 17 is from May June 18, paper 1 question 3. It says that a prokaryotic cell which is 1 micrometer in diameter is magnified to 50,000 times in an electron micrograph. They are saying that what is the diameter of the cell in the electron micrograph. As they are asking us the diameter of the cell in the electron micrograph, which means that they are asking us about the image length, right? Electron micrograph is the image which is seen from the electron microscope, right? And we know that the magnification is equal to the image length divided by the actual length. They have asked us to calculate the image length and they have given us all the units in millimeters. So we have to take a note of it that we have to calculate the image length in the millimeters. Magnification is 50,000, right? Is equal to the image length divided by actual length. Now over here they have given us the value in the micrometers, right? So how can we go from micrometers to millimeters over here? By dividing it by 1000. Now it's your choice. You can over here solve it in the micrometers first and then convert it into millimeters, or directly convert it into millimeters, right? So we are going to divide 1 by 1000 and then we are going to multiply the value by 50,000. The answer that we will get is 50 millimeters, right? The answer we are getting is 50 millimeters, and let's see where is 50 millimeters over here. This is 50 millimeters, 5.0 into 10 raised to the power 1. So we will move the point over here, so we are going to get 50 millimeters, right? Hence the correct answer for this question is option C. I hope that this is clear to all of you. Let's now move on to question 18, which is from October-November 2017, paper 1 to question 1. They are saying that which equation for calculating the actual size of a specimen A or the image size I or magnification M is correct. We should know the formula for the magnification for this, that the formula for the magnification is the image length divided by the actual length. Now they are saying that which formula can be correct for any of these, right? If we make M the subject, so which formula can be correct? If we make A the subject, so which formula can be correct, right? And if we make I the subject, so which formula can be correct? So if I talk about A over here, so this is incorrect, right? And then over here also for the actual length, this formula is incorrect. For the image length, you can see that magnification is multiplying by the actual length, not dividing. So this is also incorrect. Then over here you can see that this is the correct formula where the magnification is equal to the image length divided by the actual length. Hence the correct answer for this MCQ would be option D. Alright, so now let's move on to question 19 over here, which is from March 2018, paper 1 to question 2. Over here in this question, they are saying that a student was asked to use a scale bar shown to calculate the magnification of a cell on the photomicrograph. Alright, so a scale bar is shown over here, which is of 2 micrometer, which means that this is the actual length over here. Which method could the student used to calculate the magnification of the cell? Very simple question. We know that magnification is equal to the image length divided by the actual length. They are asking us that how we are going to calculate the magnification. We know that the actual length over here is given to be about 2 micrometers. What we are going to do then we are going to keep a scale over here on this scale bar, and we are going to measure the length from the scale, right? And then we are going to convert it from centimeters to millimeters, and then from millimeters to micrometers by multiplying it by 1000. So over here let's read the statements one by one. I think I have seen the correct answer, which is measure the length of the scale bar in millimeters and then convert it into micrometers and divide it by 2, right? We will convert it into micrometers, the image length, and then we are going to divide it by 2. So we are going to get our correct answer, right? So hence the correct answer for this MCQ is option C. Obviously option A, B and D cannot be our correct answer because they are saying that divide the diameter of the cell by the length of the scale bar. No. Measure the diameter of the cell in millimeters, multiply by 2000. No, doesn't make sense. Why do we have to multiply it by 2000, right? Measure the length of the scale bar in millimeter, convert it into micrometer, multiply it by 2. No, we don't have to multiply it by 2. We have to divide it by 2. Right? Because image length divided by the actual length hota hai. So hence the correct answer over here is option C. Now let's move on to question 20, which is from March 2018, paper 1 to question 3. It says that which eyepiece and the objective lens combination of a light microscope allows the greatest number of cells in a field of view to be seen. If there is for example an object, and if it will be enlarged with the light microscope, so we are going to see the less number of cells in a field of view, right? And if that magnification will be less, so we are going to see more number of cells in a field of view, right? So basically we have to see for an answer where the magnification is the least. In the least magnification you will see the greatest number of cells. Obviously if an image will be enlarged, you are going to see less number of cells, right? So we know that the magnification is the product of eyepiece lens value into the objective lens value. So it will come to be, its magnification will be into 50, and then over here it would be into 200, into 100 and into 400, right? So in the question, as you can see, they are saying that allows the greatest number of cells, right? So it will be with the lowest magnification. So hence the correct answer for this MCQ would be option A, which has the lowest magnification, which is into 50, right? I hope that you got it. Alright, so now let's move on to question 21 over here, which is from May June 14 paper 1 question 1. They are saying that what describes an electron microscope in comparison with the light microscope. If I talk about the magnification of the light microscope, if I talk about the magnification of the light microscope, so the magnification of the light microscope is typically from into 1500 to into 2000 approximately, right? And if I talk about the electron microscope magnification, so it can be up to 1 million, right? It can be up to 1 million. So hence the magnification of the electron microscope is basically higher than the light microscope, right? And if I talk about the resolution, so resolution is dependent on the wavelength, and we know that the electron beam has a much lower wavelength, right? Which means that it has a wavelength of 1 nanometer approximately. And if I talk about the light microscope where the visible light is used, so over then the visible light, the wavelength is from approximately 400 nanometers to 700 nanometers, right? And if we talk about the resolution, so resolution is wavelength divided by 2. 1 divided by 2 is equal to 0.5 nanometers, and 400 divided by 2 is equal to 200 nanometers, which means that the 2 points will have to be at a distance equal to 0.5 nanometers or greater to be visible as the separate points, right? And for the light microscope, it must be 200 nanometers or greater. So hence the resolution will be much better with the electron microscope, right? Hence the correct answer over here would be option A, that both the magnification and the resolution is higher for the electron microscope than the light microscope. I hope that you got it. Now let's move on to question 22. Alright, so now let's move on to question 22 over here, which is from October November 16 paper 1 to question 1. It says that until recently the typical viruses known to scientists were 20 to 150 nanometers in size. In 2003, the Mimi virus was discovered with a size of approximately 680 nanometers, and in 2013, the Pandora virus was discovered, which has a size of over 1000 nanometers. Then they say that which viruses can be seen using both a light microscope with a maximum resolution of 0.25 micrometers and an electron microscope. Alright, so we know that for the light microscope, what is the minimum resolution you should require? As in the light microscope, we use a visible light and it has a wavelength from 400 to 700 nanometers, and resolution is equal to wavelength divided by 2. So if we divide 400 divided by 2, so it will be 200 nanometers, right? And for the electron microscope, 1 nanometer divided by 2 is equal to 0.5 nanometers. Now they are saying that what can be seen by both using a light microscope as well as the electron microscope. So we know that from the light microscope 200 nanometers or above objects can be seen, and for the electron microscope the 0.5 nanometers or above objects can be seen. So a typical virus can obviously not be seen by the light microscope, right? Because 200 nanometer or above can be seen with the light microscope. However, for the electron micrograph it can be seen, but from the light microscope it cannot be seen, hence cross. Mimi virus is a 680 nanometers, which is above both 200 nanometers and 0.5 nanometers, so it can be seen. Pandora virus 1000 nanometers, it also can be seen by both the electron and the light microscope. Hence the correct answer for this MCQ is option B. In question 23, they are saying in question 23, which is from February March 2019, paper 1 to question 2, which is the second last question of the topical MCQs of cell microscopy. It says that the diameter of the red blood cell in a diagram was measured as 2.5 centimeters. The actual diameter of the red blood cell was 7 micrometers. Which calculation would give the correct magnification for the red blood cells in the diagram? So we know that as the actual diameter is in the micrometer unit, so we have to calculate the centimeters also into the micrometer. So centimeters to millimeters and then from millimeters to micrometers. We know that we have to go from centimeters to millimeters by multiplying by 10 and millimeters to micrometers by multiplying it by 1000. So hence the correct answer over here would be 25,000 divided by 7, which would be option C would be our correct answer. Now question 24 is from May-June 2019 paper 1 to question 2. It says that what is the typical resolution of a microscope using daylight as a light source with a into 10 eyepiece lens and into 40 objective lens. Now you must understand that resolution is independent of magnification. They are confusing you in the question by giving you the magnification, right? So resolution is independent of the magnification. However, resolution is dependent on the wavelength. We know that resolution is equal to the wavelength divided by 2, and over here as they are saying that microscope, they are determining the typical resolution of a microscope using the daylight as a light source. So it means that they are talking about the visible light over here, right? And visible light has a range of 400 to 700 nanometers wavelength, right? The wavelength range of the visible light is 400 to 700 nanometers. So what could be the typical resolution of a microscope of using a visible light? So we can over here do 400 divided by 2, which is the minimum wavelength, right? So it will give you the limit of resolution, which is 200 nanometers is coming about to be the limit of resolution over here. Like they are saying that the objects which will be 200 nanometers distance apart or more will be able to be visible with this type of the microscope, right? So it is the typical resolution of the microscope. Hence the correct answer over here would be option B, 200 nanometers. I hope that you are getting it and this MCQ is clear to all of you. So this was our last question from the topical MCQs of cell structure, specifically discussing the microscopy question. I hope that you guys enjoyed solving these past papers with me, and if you guys did, then do consider subscribing this channel and do leave your comment that how do you find these lectures, are they useful for you or not, and which type of past papers you want me to solve more. Alright everyone, thank you so much, have a nice day.